Whew.
Things breaking? What happened last year?
Just like last summer.
Last
There was
summer
eons the entire
It
summer.
was during Senate. It was my shift where it broke.
Oof. That must have been
It was madness.
come on, you got it. Madness.
Threw in eons. We forgot to put the flags out. Senate was really annoyed. I was like,
It's so that they get annoyed about everything.
okay, can you? But it is here just in case you need it.
Okay. Cool.
Trying. Reactor's working though, so.
Yeah, I just need to reference some stuff on the computer, so it's not like I'm not like using the computer,
Yeah.
just kind of looking at it.
Move everything however you need, so. And then we'll be out of here in like a couple minutes.
Coolio.
Sorry about this.
No, it's all good. I'm gonna be standing like right here. This is kind of in the way. Can you see the screen from here, or am I in your way?
Oh, you're in the way.
Yeah.
Not very mobile, but it is safe. It's not very mobile, but it's safe. I have tripped it for that.
That tiny switch.
It's a little.
All right.
Alright, got it. No, that should be good. Hopefully nothing else breaks.
Good luck, everyone.
What time is it? Is it time to start yet, or not really? Yeah, it's sort of time to start. Am I muted? Or I'm on? Alrighty. So, my name is Gabriel. I am the Quant Tools tutor for SARC. So what I plan to do today is since you guys are familiar with the portal online, I plan to be using the final exam prep, and that's in your study plan. And you can view this video later and just kind of follow along if you want to go back. But I'll be running pretty much through a majority of those problems, so that way you guys have something to base it off of. Because I'm not going to be like, I can't do that and do the work at the same time on the board, so I'm just going to be kind of writing down the problems, and then you guys can just kind of follow along when I write it down. Does that make sense? Cool. So okay, let's get started. So the first bit of Quant Tools, it deals mainly with linear algebra, so it's not too bad. So I'm gonna try my best to kind of run through that. And if you guys have any questions, just stop me at any time, and I can try to explain something a different way or a better way. So yeah, alrighty. So first problem is finding slope. Now here on the problem it says it's 4x equals 18. All right, so here we need to find our slope, and we know from our equations y equals mx plus b, we know slope is the number in front of x. So first we need to set this equation into a y equals mx plus b form. So all you're doing here is you're going to solve for y. So it's pretty straightforward. You just want to get y by itself. So you're going to subtract the 4x. Subtract the 4x. So that leaves you with negative 9y equals negative 4x plus 18. And that's what's happening there. And then you divide by negative 9 on both numbers. You can divide negative 9 by the whole thing or individually. I suggest to do it individually because it's just a little bit easier to cut down on your steps. So you have y equals positive 4/9 x minus 2. Now, does that make sense to you guys? It's pretty straightforward. You're just solving for y. Here, we only care about the slope if it exists. Obviously, it exists in this one because there's a number in front of x. So our slope is just 4/9. And that's pretty much it for that first problem. So yeah, let's move on. Alrighty. So the next problem is they want you to express kind of a word problem in a linear through a linear problem or through a linear equation. So here they say your givens are. Let's scoot this up. Here it says fixed cost is $100. 30, and it says, it kind of gives you a number to plug in. It says 30 items cost $1,300 to produce. Cost $1,300 to produce. 30 items cost $1,300 to produce. So here we actually need to kind of find out what that linear equation is. So you're going to go back off that same formula of y equals mx plus b. Cool. When it comes to word problems, usually 99% of the time when you see a fixed number, that's usually going to be your b. So here we have, this is essentially our x value, and this is essentially our y value. So here we're going to solve for m, and then we're going to plug back our b to give us our equation. So I'm just going to start off writing down y is 1,300. We don't know m, so we're going to leave it as m. We know our x is 30, so that's going to be 30 plus 100. This 100, again, is our fixed cost. That's the number you tack on at the end of something. So here, we're going to be solving for m. So what you would do is subtract the 100. So this gives you 1,200 equals 30m. And we're going to divide by 30. Divide by 30, and I believe m would equal 40. I'm just going to double check it really quick. So yeah, so 1,200 divided by 30 is going to be 40. So now that we know our m is 40, we can kind of use our fixed cost function and our m to plug back into the equation, giving us y equals 40x plus 100. And this would be our linear cost equation. Pretty straightforward. It's not too bad. So yeah, there's that. Do you guys, does that make sense? Cool. Now again, for whoever's like joining online, I'm using the final exam prep from your My Math Lab, so you can follow me along there if you guys can. Alrighty. So let's see. Alrighty. So I cannot show the graph, so I'm gonna move on to the stuff that I can show you guys. Alrighty. So here, number 4. It's a word problem, and they say we want to find an equation for a number of T-shirts that are being sold. So it says here, whenever you see marginal cost is most likely always going to be your slope. So here they say her marginal cost to produce one T-shirt is $3.50. So that means if a marginal cost is $3.50, that means technically your slope is $3.50. Her total cost to produce 40 T-shirts is $230. Now what that means is kind of like that last problem we did. We have an x value and we have a y value. So here they say our x value would be 40 t-shirts, and the total cost y, usually y equals would be the total cost of a function most of the time. In your guys' case, I don't think that'll change, but usually your total cost is going to be your y. So the total cost to produce 40 t-shirts is $230. So again, we're in that same situation where we have a point and we have a slope. So we're just kind of looking for the equation of the line. So we know the equation is y equals mx plus b. We know our m and we know our x and y. So we're just going to go ahead and plug them in and solve for b, because we don't know our fixed costs. Plus b. So we have that number here, so we're going to do 3.5 times 40. And that's going to give us 140. So we have 230 equals 140 plus b. Now here we just need to solve for b, so we're going to subtract 140. So 230 minus 140 is going to be 90. So here we know our b and we know our m. Cool. So since we know our b and our m, we can easily find out the equation by just sticking it into the equation. So y equals 350x plus 90. Now, looking back at that problem is just kind of what is her cost function to create, to make these t-shirts. So that would be that first part of that problem. The next part of the problem says we need to find out how many shirts she needs to sell to break even. So what that means is we need to find out how many shirts it would take her to give her a cost of 0, basically. So what happens here is we're going to be doing, actually give me 1 second. Okay. Yeah, so what happens here is we need to produce to sell t-shirts to break even. So we need to make sure, okay, total cost. Okay. So give me 1 second, guys. This thing is just, yes. Oh, I'm sorry, you just came in. I'm working from just the final exam prep from the portal Pearson from the My Math Lab. So I'm just doing that real quick. Give me 1 second, guys. Sorry about the delay. Okay. Okay, sorry about that. Let me just start this back over. Okay. Okay, so, there we go. Okay. Okay. So here, we're trying to find when she breaks even. Now remember, for you to break even, you want to make sure your revenues equals your cost, right? So when it comes to revenues, we know our revenue is basically how much we sell at what price we're selling them at. So for here, all right, here she sells them for $9 each. So that means our revenue function, since she sells t-shirts at $9 each, we can find her revenue by doing sales times the price. So in this case, it'll be 9x. So this will be our revenue function. We know our cost function because we solved for the cost function earlier. So this is our cost function of 350 plus 9. And to break even, all you need to do to break even is to just make sure you want to basically set your revenues equal to cost. So that's what we're going to do here. Okay. So solving for x will give us the number of t-shirts it'll take for her to break even, basically. So we're going to solve for x, subtract 350. This is going to be 550x equals 90. You solve for x by dividing by 550. Can you guys see that? A little bit more. Can you see that, Mary?
Yeah, I can see. You said from the final exam prep.
Yeah, from the final exam prep. Yeah.
This is question 1.
No, this is question 4.
Oh.
Yeah. 5.5. And we're dividing that by 90. So we get 5.5x, 5.5x. So in this case, we get 16.36. Now you want to be careful. Since we're dealing with a word problem, we're dealing with something that's physical. So we can't sell a third of a t-shirt. So in this case, we're going to round upwards to the nearest number. So the number of t-shirts it'll take to break even would be 17 t-shirts. Does that make sense, everyone? So for you guys coming in, I'm just working on the final exam prep from the My Math Lab. So if you guys can pull that up and just kind of follow me along there, I'll be doing the problems that are that don't deal with the graphs, and I'll cover graphs if we have time afterwards. Okay. Oh, and the next question says here, we're still on the t-shirts problem. The next question says, how many t-shirts must she produce to sell to make a profit of 500? So here we know that profit is revenue minus cost. So here we can kind of make a profit equation by doing our revenue function minus our cost function. So we can just kind of do that here real quick. So we can do 9x minus 3.5x plus, actually here it would be minus 90. When you're subtracting functions, you want to make sure you're subtracting them through the parentheses. So that way, I'll make this a plus here so I can show you. When you're subtracting functions as a whole, you have to distribute your negative to both numbers. So technically this would be this 9x minus 3.5x minus 90. We know that 9x minus 3.5x is 5.5x, so minus 90. So this is essentially our profit function. Now here we want to find a profit. We want to see how many t-shirts does it take to make a profit of $500. So all you're going to be doing is plugging in 500 into your profit variable, essentially, because we're trying to find x, and x again is the number of t-shirts that we are selling. So here we're trying to make a profit. In this case, we're trying to make a profit of $600, and all we're doing here is we are solving for x because it tells us how many t-shirts will it take to get us to that number. So here you're going to add 90 to both sides. So this becomes 690 equals 5.5x divided by 5.5x, or not x, sorry, just the 5.5. And you plug it in your calculator and you should get 125 t-shirts. Does that make sense, everyone? All I'm doing is just solving for x, so that tells us how many t-shirts we need to sell to break even. Or in this case, sorry, make a profit of $600. And again, in this case, we end up with a number 125.45. But again, think in the terms of the problem, we can't sell 4/45 of a t-shirt, so we're going to round up to our nearest number. So our number of t-shirts would be 126. Cool. Does that make sense, everybody? Cool. Alrighty. So here we are. Huh?
What was it to break even?
We're first to break even. We set our revenues equal to cost. So if you see here, we find our revenue function is the number of, is basically how much we sold how much we can sell our t-shirts for. In this case, we can sell them for $9, and the revenue would be $9 times X, because that's how many t-shirts, and that's revenue. And to break even would be revenues equals cost. And that's what I did here. Revenues equals cost to break even.
So you have to write R of X equals 9X?
Yes, because that's our, you don't really have to, but that's your revenue function. I'm just kind of listing everything out. Does that make sense? Cool. All right, so question number 5, we're kind of jumping the boat, and I brought a kind of like a formula list for some of the important formulas I think would probably be on the test based on the final exam prep we have here. In this case, we'll be dealing, for this next problem, we'll be dealing with simple interest. Simple interest is just a quick formula of I equals PRT, and let's go on with that. So this problem says, it just asks you to find simple interest. So the interest, and they're going to give you 3 numbers, and we're just trying to find our simple interest. So again, our formula is I equals PRT. They say our P is going to be 1974. Our R is 6.5%. And our T is going to be 30 weeks. Yeah, I'm going to slide it down. There we go. Cool. So at this point, we're almost going to be plugging in straight up, but you want to be careful because we need to change our percentage into our decimal, and we need to change our weeks into years. So those are fairly simple. The 1974 stays the same. Now your rate, since it is 6.5%, you want to change it to a decimal. An easy way to do that is to just divide by 100, and that'll tell you your decimal number. So in this case, it's going to be 0.065. Now your time in weeks, you need to change that time into years. Since we'll be using weeks as our basis, we need to know how many weeks are in a year. We know there's 52 weeks, so that means we can proportion 30 weeks over 52 to be our numbers in years. So we're essentially doing 30 divided by 52 because there's 52 weeks in a whole year, and we're just kind of finding that proportion of 30 over 52. And here, now it's just a calculator problem. You're just multiplying it all straight through. And when you calculate it, we should get interest of 74.02 or 03, depending on the rounding. But this is fairly straightforward. It's not too bad. It's just a simple plug and chug. You want to be careful on making sure your decimal is or making sure your percentage is in a decimal, and making sure your weeks are in years, depending how they want you to phrase it. If they were to say 200 days, you would make it 200 over 365. Does that make sense, everyone? It's pretty. It's not too bad. Cool. All right, so we're on question 6 for the final exam practice quiz for those of you joining. So question 6, it's going to be a little complicated because we'll be doing with annuities. So, okay. So the formula for the annuity in this case is going to be S equals R of 1 plus I to the n minus 1 all over I. So what this formula is basically telling you how many payments are we going to need to either pay off a house or pay off a loan. It is not, it's not too bad. It's just you want to make sure you're using the right numbers. You don't want to mess these up. So, and here we go. So I'm going to write down the definitions of the thing. So here in our case, we're going to be using R is basically the number is the payment itself. I is obviously our interest rate per period. And our N is the number of periods. So what that means is of periods. What that means is, for instance, if we have a semi-annual annuity, that means we have 2 periods per year. If you have a quarterly period or quarterly periods, then we have 4 periods throughout a whole year. So it's not too tricky. You just want to be careful on how many periods there are. So in this problem, they tell us our R is going to be 6,000. Our interest is 6% compounded semi-annually. So we're going to just put it up here. Semi-annually, and since we know it's semi-annually, we have 2 periods per year. So our n is not 2. Our n is going to be dependent on how many years there are. So I'm going to put t here. Our t is 6 years. So that means our n would be 6 times 2. Does that make sense, everyone? It's just the number of years you have times the number of periods per year. So our n is 12 in this case. So semi-annual, yeah. If it was quarterly, you would use 4. If it's monthly, you would use 12. So you're just kind of following how many periods we're having. So, alrighty. So we know that our I is going to be 6% semi-annually. So in our case, since we're doing semi-annual payments, we have to divide that percentage by 2. So our I that we're going to use is 3%, or we have to change to a decimal to use for calculations, 0.03. Does that make sense, everyone? You want to make sure you divide your interest by however many periods we're having per year. So we have our important numbers. We got this one, this, and this. So at this point, you're just plugging in your numbers. What I can suggest to put it in the calculator, because I do not believe you guys are allowed to have like graphing calculators or like computer assisted calculators. So what I would do is I would work from the inside out. And what I mean by that is you start off in the middle of the 1.03. You're going to add those 1 and the 0.03 together, raise it to the 12th, subtract it by 1. Oh, this should be a 0.03, sorry. Subtract it by 1, divide by 0.03, and then multiply it by 6,000. And that should give you your annuity payments, or annuity due, yes.
Is that a 1 plus 0.03?
Yes, 1 plus 0.03. I'll try to write bigger so that way everyone can see. Does that make sense though? Oh yeah, I'm going to put it up right now. So when you plug it in your calculator, we should get 131,985.87. Now you want to be careful. That rounding could differ depending on how many decimal places you guys do it. But this is basically the process for that. And if you guys have any more questions on this, I'll answer that like after this, because I do want to move on so we can get through it quickly. You have a question? Here? Yeah, this is 1 plus I, so it's 1 plus 0.03. So it becomes 1.03. Does that make sense? Cool. Yeah, I put an I here. I meant to just make it 0.03. It should have been a 0.03. Cool. So let's move on. Okay. So, alrighty. All right, so the next problem, it's going to be, and this is problem number 7 on the final exam prep, so you guys can follow along. So this other problem, you want to be careful because it uses the same formula. However, we're going to be solving for I in this case. Yes. So here, I'm going to start off with a new piece of paper. We're still using the same formula of S equals that that R stuff. So I'm going to write that down. Okay, make sure. Huh? Oh, I'm doing number 7 on the final.
Number 6, if I may ask, it still has 2 sections, which is calculating the amount of contribution and amount of interest.
Oh, okay.
How do you extract that?
Okay. I'm sorry. I totally skipped over it. I didn't see that. My bad. So, amount from contributions. Okay. So basically, for the amount of contributions, it's kind of saying how many payments you're doing times however many times you're paying it out. So your contributions would be the number of payments times the number of periods you're throwing in. So in this case, our contributions would be the yes, R times T, or R times N essentially, because we have 2 payments per year, but we have 6 years. That makes sense? Yeah. And we want to find the next part, I believe. Actually, that was it, correct? For the contributions? Yeah. So yeah, does that make sense? Cool. Alrighty, next question. Yes, I'm sorry.
You said you minus, for the second part, it says and the amount from interest is?
Basically, the amount we paid for contributions minus S. So the number of,
We got in the first portion?
yes, that minus that.
What is what? I'm sorry.
Oh, I'm sorry. So for the contributions, I'll look over the numbers with you guys. I just want to move forward because I don't want to spend too much time on that. Sorry about that. So the amount of contributions would be R times the N, because that is basically saying how many payments we're doing times how many times we're doing those payments, and we're doing those 12 times all throughout. And then it says the amount from interest. Amount from interest would be the contributions minus what we solved to begin with. Then basically the present value of the annuity. But I'll go over those numbers with you guys if they're not working out. Alrighty. I lost that. Okay. Okay, so number 7, we're using the same formula of S so we're using the same formula. However, we want to find the interest rate. So in this case, we're going to be doing some kind of backwards work to find I. So in this problem, they say our S is going to be 27,202. Our hour is going to be 950. And we have T is 6 years. T is 6 years at quarterly. And quarterly we know is 4 times a year, per year, or a year. So our N is going to be 24. Does that make sense? To find our N, we just have the years by the number of periods. So yeah, interest rate. So we're solving for interest, so we're just going to be plugging in numbers and solving for interest. So we have S at 27,202 equals R of 950 plus I. And now remember, technically our I in this case is going to be I divided by 4 since we have quarterly payments per year. So technically this would be over 4 in this case. Over 4. And remember we are solving for I. Does that make sense where I'm at right now? All I'm doing is I'm just plugging in numbers at this point. So here we want to solve for I, so we want to get 950 by itself. So we're going to be doing 2702 divided by 950. Okay. So we get a decimal around 28.63 equals, we got this right here, minus 1 all over I to the 4th. Alrighty, so this part can be tricky, so let me make sure I am in the right spot. Okay, so okay. Okay. So I am actually going to skip this for now because this will take too long. I don't want to spend too much time. I will go back to this over with you guys personally. Sorry, I thought this problem would be a little simpler than that. So I'm going to skip this one now, but I will come back to you guys if you guys have any questions on that. So I'm going to move on to question 9. So question 9 starts off with probability and stat. You have a question, Mary?
I thought that was 7 we were skipping.
Oh no, I'm skipping over 7 and 8 because they're both dealing with the same annuity stuff, and I don't want to spend too much time on that. I want to get through as much as I can as possible.
Can you just plug in on tests?
Yeah, one thing that's a good point. Since this test will be multiple choice, an easy thing for you to kind of hint out is to plug in the answers from the multiple choice to see which numbers match up. That is one way of figuring it out as a fail-safe for you guys. I would like to go over it, but I just want to move on for now. Okay. All right. So right now I'm going to be doing question number 9, and this starts off with our probability and stat section. I know, Mary, it's not your favorite. It's not my favorite either, but it's not too bad for these problems. So here, question number 9 says a single fair die is rolled. You want to find the probability of getting a 2. So we all know a die has 6 sides to it. We only want to roll one number from it. So basically, we're just doing our number of events that we want over the total number of outcomes. So technically, that would be kind of the event that we want. I was taught like this. So in this case, we want to roll a 2. A 2 can only happen one time. When you roll a die one time, we have a total number of 6 sides. So our total number of events that we can roll would be 6. So the probability of rolling a 2 out of a fair-sided die would be 1 out of 6. Does that make sense, everyone? Pretty straightforward. It's not too bad. Yes.
So it doesn't matter what the number is.
And yeah,
It's gonna be 1 out of 6.
yeah. When it comes to rolling die, if you're just rolling one number, it's always going to be 1 out of 6. Alrighty. So here, question number 10, kind of the same deal. We're dealt one card from a standard 52 card deck. We want to find the probability of dealing a 4. So if you guys know cards, we know there's 4 of everything in each deck. So we know that there's 4 events that we can pull out, 4, and we know the total number of cards that we are doing would be 52. So our probability of rolling, or not rolling, but pulling a 4 out from a deck will be 4 out of 52. Most likely that number will be reduced or simplified, so you can just kind of reduce it. In this case, these both numbers are divisible by 4, so we're going to divide both numbers by 4, and our probability would be 1 out of 13. Does that make sense, everyone? It's not too bad. You're just pulling cards out of a deck. Alrighty. Okay, so here, still on the same subject of probability. The problem says find the probability of pulling a club or a heart. So in this case, when you have 2 separate options that can happen, you add those probabilities together to get your total probability in a sense. So we know that there's 13 cards of each suit in the deck. So we know that there's 13 hearts out of 52, or in this case, yeah, 13 hearts. And we know there's going to be 13 clubs. So if we pull out 13 clubs, it's just going to be the same number essentially. And then at this point, you're just adding fractions. 13 plus 13 is 26 out of 52. This can reduce to 1/2, so you have a 50-50 chance of pulling out a club or a heart, or any two separate combinations of cards or suites. Cool. Alrighty. So the next one is we have more probability. Sorry, guys. We have a box of gumdrops. So I'm just going to write down the table. We have a lemon gumdrop, a 4, orange, all right. So here's a makeshift table of what we have. Alrighty, so we want to find the probability of pulling an orange gumdrop. Same kind of concept, how many events that we're trying to pull out of the total number of events that can happen. So the total number of events, we first have to find that ourselves. So we're just doing 4 plus 5 plus 6 plus 5. 4 plus 6 is 10. 5 plus 5 is also 10. So our total number would be 20. We want to find out what is the probability of pulling out an orange. So it's the number of oranges over the total number of gumdrops. So the orange would be 5 out of 20. 5 out of 20 can be reduced to 1/4. So you have a 25% chance of pulling an orange gumdrop. If you wanted to pull out grape gumdrop, if you guys can read my handwriting a little bit. If you want to pull out a grape gumdrop, it's the same kind of concept. However, it's going to be 6 over 20. Does that make sense? It's not too bad. You're just kind of number of things you want over the total number of things that can happen. So 6 out of 20 can be reduced, divided by 2. This would be 3 over 10. So you would have a 30% chance of pulling out a grape gumdrop. Cool. Does that make sense, everyone? Coolio, coolio. Alrighty, so this one is it's not my favorite, it's not Mary's favorite either. We're doing more probability, but now we're rolling. We want to find, oops, I'm sorry. So here, we want to find the probability of getting a sum of 4. So what that means is when we roll 2 pairs of dice, we can add those 2 numbers together to get a number, correct? So in this case, we want to find out what's the probability of rolling 2 dice to give us a 4. So before I wrote this, we have a table that is super useful. I would kind of like you guys to kind of quickly jot this down. So what this table is, if you guys can see that, yeah. So what this table is basically all the total combinations of summing 2 pairs of die. Starts off at the top of summing a 2. The only way you can get a 2 is rolling 2 ones. So there's only one combination of it doing that. And I just go down the list, kind of numbering one by one by one. So for instance, we want to find the probability of rolling a 4, rolling a sum of 4. So what that means is we need to find out, how many different combinations of 4 there are over the total amount of total different amounts that we can actually roll. So I went ahead and did that math because no one wants to see me write all these numbers down. So the total number here between this kind of triangle would be 36. So the total number of rolling, and I'm going to put this off so you guys can either keep writing. So the total number of die would be 36. We want to find out the probability of rolling a sum of 4. So we go back to our table. There's only 3 different combinations of 4. So it's just 3 out of 36. Does that make sense? It's not too bad. The only kind of tricky part is writing down all those numbers. But yeah, so here we can reduce we can divide by 3. This becomes 1 over 12. So if I were to say a probability of rolling a sum of 7, you're just going to look at your 7 charts and see how many there are here. So we have 6 different combinations of rolling a 7. You have a question?
That 36 came from the total?
Yeah, all of those added together separately. So here we want to roll a sum of 7. We know there's 6 different combinations, so it'll just be 6 over 36. Does that make sense? Yeah, it's just number of stuff you want over the total number altogether. This can be reduced to 1 over 6. Does that make sense, everyone? I know probability is not my favorite subject on this. Alrighty. Cool. So here we need to find, we're still back on rolling die. However, we want to find the odds in favor. So what that means is we're going to be kind of setting up a ratio to kind of find our, our 2-to-1 odds or 3-to-1 odds. However, we're going to be kind of making our own ratio depending on the problem. So in this problem, we want to find the odds in favor of either rolling a 3, a 4, or a 5 with a single die. So what that means is a quick formula for finding odds in favor. It'll be the number of events that are happening over the complement of events that can happen. So what the complement is basically 1 minus p. So I'll kind of put this off to the side over here. 1 minus p to the probability of rolling these events. So we want to find the odds in favor of rolling a 3, a 4, and a 6. So we're just going to find what's the chance of rolling a 3, a 4, a 5, and a 6, and then subtracting that ratio. So we know that we're rolling 3 numbers from a die, so that's pretty straightforward. We're just doing 1/2. So we know that 1/2 is your PE. However, we need to find our P complement, which is going to be 1 minus 1/2. And in this case, it's the same thing. As P complement is going to be 1/2. So you're going to do 1/2 over 1/2. It's not too bad. So when you're dividing fractions, going back to algebra, when you divide by fractions, you multiply by the reciprocal. An easy way that I learned to kind of remember, to help me remember, is keep, change, flip. We keep the top number, we change the sign to multiplying, and we flip our bottom number. So it's 2 times 1. Now we're just multiplying straight across. You guys can see that. So we have 2 over 2. That reduces to 1 over 1. So our odds in favor of rolling a 3, a 4, or a 6 would be 1 to 1. Does that make sense? And I'm going through it pretty quickly. Yes. The 1/2. The 1/2 comes from what is the probability of rolling a 3, a 4, or a 6? We know 3 out of 6, basically. Sorry, I should have probably kind of wrote that here.
If it was just a single number, if they just said what was the probability of rolling the odds in favor of rolling a 3?
Oh, that's a good question. I was actually going to do something like that. Because the 1/2 is kind of tricky because they're both the same number. So here, if we wanted to find the odds in favor of rolling a 3, or really just any number in this case, let's say rolling a 3, we know the odds of rolling a 3 will be 1 out of 6, correct? So if you roll, so our top number is 1 out of 6. Oop, make sure you guys can see that. Remember, we're trying to find the complement, so you're basically subtracting 1 from that. So in this case, it'll just be 5 over 6. Do you see how I got the 5 over 6? Just 1 minus that. And we're just doing the same thing again. Keep, change, flip. Keep your fraction, flip, or change the sign, and you flip your fraction. You multiply straight across, so you have 6 over 30. We know we can reduce the 6 over 30 into 1 over 5. So our odds in rolling of rolling one number would be 1 to 5. Does that make sense? Yes. Cool. Does that make sense to everyone? Yeah. It's pretty. You just want to remember the P over P complement. That's the trick there. Alrighty, so I'm going to be skipping number 15. All right, so here I'll be working on number 16 on the final exam practice quiz. So here we're going to be dealing with tables. So this is the statistics part of the class. All right, so I'm going to write this table down. Now here you want to be careful because we do have kind of something a little tricky. We have intervals. So I'm just going to kind of shorten this list. Okay, so all right, so here we have a table. We're probably going to be asked a number of things from this table. So question number 16 wants you to find the mean. Now we know the mean in general is you add up all the numbers and divide by how many numbers there are, right? So in this case, we don't necessarily have specific numbers themselves. We only have intervals. So when you're dealing with the intervals, all you're doing is you're trying to find the midpoint between those 2 points. For instance, if we look at 0 and 9, we're finding the midpoint between 0 and 9. All you do is 0 plus 9 over 2. So the midpoint for that group right here would be 4.5. Does that make sense, everyone? Cool. So now we're just kind of following the same kind of pattern. So for our next group of 10 to 19, our midpoint between 10 to 19 would be 14.5. And as you see the pattern, your number is going to be ending in 4. So you can guess your next number value would be 24.5, and then we have 34.5. Does that make sense, everyone? You're just setting up the intervals midpoints as their values. So here we have different frequencies. So what that means is this number is happening 4 times, this number is happening 5 times, so on and so forth. So essentially, you're going to be multiplying by the frequency. So you have 4.5 times 4. Oops, I'm sorry, this should be a 5. Times 10. And times 9. So what this is doing is we're just kind of adding up all of we're multiplying how many different numbers we have by multiplying by how many there are. So the first one will be 4.5 times 4. That's going to be 18. 14.5 times 5. It's going to be 72.5. 24.5 times 10 will be 245. And 34.5 times 9 is going to be 310.5. All right, we're almost done. So now that you found basically the frequency times the intervals, you're going to add them up and divide by the total number of frequency that you have. So we're going to add these up. So we have 18 plus 72.5. We have a total of 646. And now you're going to be dividing by the total number of frequencies, and the total number of frequency in this case would be 4 plus 5 plus 10 plus 9. This would be 18 plus 10. Our total number would be 28. And we're dividing by 646 by 28. And our mean of the grouped set would be 2307. The problem on the final exam, it goes a little further. It has 2 more intervals, but this is the basic gist of it. It's not too bad. You're just finding the midpoint between the intervals, multiplying by the number of frequencies, adding all those up, dividing by how many frequencies we have. Does that make sense for you guys? Cool.
You
Yes.
said divide
Yes.
Not just how many are listed, but the total.
Yeah, the total. So the 4 plus 5 plus 10 plus 9 in this case. Does that make sense, Mary?
Yeah.
Cool. All right. So next question. We're still doing our stats and probability section. All right. So here we want to find the median. Median is not too bad. I'll go over 2 different examples. So this example uses these numbers.
Sorry, which problem is this again?
Oh, I'm sorry. This is going to be question number 17. Alrighty. So here we're trying to find the median. The median is not too scary. All you want to do is list your numbers from smallest to greatest and find the number in the middle. So here we have, well, mine's already smallest to greatest, so I don't have to do that. But you want to rearrange it if you have a mixed set of numbers. So here, what I like to do is I like to just kind of cover up our numbers and just get to the middle. Since we do have an odd number, we're going to have just one median. So I just cover one at a time, and then we end up with a median of 126. Does that make sense? Pretty straightforward. I know it's a little kiddish with my little fingers and stuff, but it's not too bad. However, our median for this question would be 126. However, if we were given an even number of numbers, for instance, let's make this 2, 7, 10, 13, 13, and 15. We have 6 numbers. So if we try to do kind of that same kind of strategy where we just kind of cover them up one at a time, we end up with 10 and 13 as both our medians. So when you end up with something with 2 medians, you're just going to average them out. And for you to average them, you just kind of add them together and then divide by 2. So in this case, 10 plus 13 is 23. Divided by 2, that's going to give you 11.5 for the median in this case. Does that make sense? You're just kind of finding right in the middle where that is. So that's not too bad. Cool. Okay. So now we'll be doing question 18. And I'm going to write down the numbers. Alrighty. So in this question, we're going to be finding 2 things. First one is range. Range isn't that scary either. All ranges is your biggest number minus your smallest number. So in this case, our biggest number would be our 217, and our smallest number would be the 173. So our range in this case would be 217 minus 173, which is 217 is 44, is going to be our range for this data set. Now we get the tricky part is standard deviation. So the formula for that I also wrote down. So we're going to be using this formula right here, if you can see it. Can't really, zoom in. Oh, cool. We're going to be using this formula. The square root of the sum of x minus x bar squared, all divided by n minus 1 equals s. That's essentially standard deviation for you guys. So yeah, I'll give you a second to write that down. Okay, so let's start. Alrighty, so the first thing we want to do when finding standard deviation is find the mean between all the numbers. So I'm going to write down the formula real quick. So we want to find the mean, and for you to find the mean, you total all these numbers together and divide by however many numbers there are. So in this case, we have 3, we have 7 numbers, so I'm just going to add all these up and divide by that number. Okay, so we have a total of 1330. We want to divide by how many numbers there are. There are 7 numbers. We divide that by 7. We end up with 190 as our mean. Now remember, your mean is x bar. You want to remember that. That's kind of a thing you want to kind of write down. X bar is essentially mean. So here we're going to move on to our second step. So here this says x minus x bar. So what we're going to do is we're going to individually subtract all of these numbers by the mean. All right. So we're just going to be I'm going to write it off over here. So we're going to do this minus 190, this minus 190, this minus 190, so on and so forth. Does that make sense, everyone? Or we're just kind of just subtracting x minus x bar. You have a question?
Can you just add all the x's up and subtract it by 1?
Essentially, you could. Well, no, you need to have them individual because we need to square them afterwards. If you can find a way that it makes sense for you guys, more power to you. It's awesome, but I just want to stick to just the normal way of figuring it out. So I'm going to be writing them right here. So 188 minus 90 is negative 2.
Would you ever have a negative?
Yes.
Oh, okay.
Yeah. We're having negatives right now. Okay, so forgive me, my kind of work is kind of a little all over the place, but we have this going on right here. So now that we subtracted all our x's and our x bars, the next step is to square all of these numbers. So we're just going to square all these numbers. Alrighty, so now that we squared all the numbers, we're going to do our next step, which is the sum of all the numbers squared. So we're essentially just going to add all these numbers together. So here we go. All right, so when I summed all these numbers together, I got 1140. Now you've essentially completed that top part, and that's basically the hardest part, just because it's long and it's tedious and it's easy to make mistakes there. So this is kind of the top part, which is the sum of x minus x bar squared. And now we're just going to finish it off. So we're going to divide by n minus 1. Now what n minus 1 is the number of observations we have minus 1. So in this case, we have 7 observations. We have 7 observations, so n minus 1 will be 6. And you're going to square root all of that together. So 1140 divided by 6, square root it, and we should get when you divide 1140 by 6, we get 190. It's a coincidence that it equals x bar. That's not always going to be the case. Square rooted, and we get 13, and let's put it over here, 13.78 as our standard deviation.
What did you say sigma was?
What?
What did you say sigma was?
Sigma was the sum. the sum of all of these things added together, and we're summing x minus x bar squared, and we're adding all these squareds together. So the sigma is kind of here. Does that make sense? Cool. Alrighty, and that's essentially standard deviation. You just want to be careful of what you're subtracting, what you find your x bar, and just plugging it in the formula. All right? Okay. Alrighty, so now we're going to do it again, but we're going to be doing it with a table. So I'm just going to kind of make a makeshift table that's not too intense, so we can save some time. So it's going to be just like our interval table before. We have two different intervals, or we have multiple different intervals. All right, so I'm just going to shorten it here. It extends a little bit more, and this is question 19 on the final exam practice quiz on your My Math Lab. All righty. Okay. Cool. So what we're doing here is essentially the same thing. We want to find standard deviation of our table set. So we're going to kind of use a modified formula of the standard deviation since we do have the midpoint stuff to worry about. And what this is the square root of the sum of frequency times x squared minus n times x bar squared. So what that means is, I'll show you in a second actually. So this is essentially the formula. So if you guys can write that down really quick. Okay. So our first step always when you're trying to find standard deviation is you want to find the mean. So remember, when it comes to finding the mean for these tables, you want to first find the midpoint between these intervals. So essentially you're doing the same thing where you have 0 plus 4 divided by 2. That's going to be 2. So our first midpoint essentially would be 2. 5 plus 9 divided by 4. No, divided by 2, I'm sorry. It's going to be, actually, let's put this right here. This is going to be 7, so 2, 7, 10 plus 14. And here, once you get to the third one, you can start to see the pattern. So I guess we can assume the next one to be 17. I'm going to run through it anyways. So 15 plus 19 is 34. 34 divided by 2 is 17. So this is essentially kind of our pattern here. To find the mean, remember you want to multiply all your intervals by the number of frequencies and then divide it by the total number of frequencies. 3 plus 3 is 6. Plus 6 is 12. So our total number of frequency is 16. So we're just going to be kind of multiplying them out separately over here. So we have 8, 21, 72, and I believe 51. Yes. 51. So now that we have we multiply them out, we're going to add them all together, divide by the total number. Oh, I'm sorry. Oh, I got to zoom out actually. There. Sorry about that. Cool. We're essentially adding all these up together. So we get a total of 152. Our total frequencies over here would be 16. So 152 divided by 16. We get 9.5 essentially as our x bar. Okay? Cool. Does that make sense, everyone? We just kind of quickly did what we did a couple problems ago. So here, we look back to the formula, which is so here we found our x bar. We have the number of n, which is 16. Now we just need to find the sum of x squared times f. So essentially what we will be doing is squaring the x, multiplying it by each frequency, and then adding all those numbers together. So kind of off to the side over here, this is x bar. Yes?
Sorry. In your formula, the sum of f of x squared minus, what is that?
And
Oh, n times
yeah, yeah. N is a number of kind of like the, it's almost like the number of frequency, basically, the total number of frequencies. So, all right. So here we are essentially doing the x squared, which in our case, our x's are going to be these. We're going to square them, times them by their frequencies, and add them all up together. So now we're just going to be doing kind of like a modified version of this. However, now we're going to be squaring them. Does that make sense? We're just kind of doing a little modification to our list. So now we kind of have kind of like a comma here. I don't want you to confuse that. Now keep in mind, I do not, I feel like this problem might be a little too much to be on the test, but I just want to make sure that it's covered so you guys, if it is on the test, you're not too surprised. So now that we found, now this is essentially, oh, I'm sorry. Yeah, so now I squared these to kind of modify our list earlier. So now this is essentially the sum of fx squared. So now we're going to be adding all these two together. So forgive me again, my work is not the neatest right now. So when I total this up, I end up with an f of x squared, sum of x squared, 1894. We know that our x bar is 9.5. Our total number of observations is almost the same thing as our total number of frequencies, is 16. Does that make sense? Everyone, make sense? Cool. So 16 is our n, and we can now plug it into our formula. So 18. So I'm going to go ahead and multiply 9.5 times 16. And remember, this is all over the n minus 1. N minus 1 in this case would be 15. And it's all square rooted. So we're doing 1894 minus 152 divided by 15. And we're going to square root this. Yeah, you square root at the very end. That's our last step. And I ended up with s equals 10.78 or 79 depending on rounding. And that would be standard deviation using the intervals and all that good stuff. Again, this is I think this is a little too time consuming to be on the test, but I still want to cover it just to make sure you guys have all the bases touched. Alrighty. So now we're going to be working on the pre-calc section of the course. This is starting with question 20. Okay. So question 20 on the final exam prep is talking about limits. Now, one thing I do want to preface with limits is there is one condition for limits to actually exist. Essentially, the rule is the limit as x approaches. Zoom in. The rule is essentially as x approaches a from the left side equals, I don't know, some number. Let's make it 2. And the limit as x approaches a from the right side equals 2. Now, the rule essentially is this. If the two limits equal the same thing when you approach it from both sides, that means the limit exists at that point. Exists at 2. Does that make sense for you guys? This is kind of like you need these two things to occur first before you can assume it exists. And the rule is these two things need to equal the same. So for instance, if we were given a problem like this, as x approaches 7 from the left side and the limit as x approaches 7 from the right side, if this equals 2 or equals 1 and this equals 3, here we can't say this limit exists because they do not equal the same value at, or for them to be the same. So it does not exist at all, and you can say D and E. That's essentially the rule. Now, that would be kind of a major staple when it comes to limits. So yeah. Now question number 9 is a little bit different, but it's very similar to just almost basic algebra. It's not too bad. So question number 9 says the limit, question number 20, I'm sorry, thank you, Mary. Yeah, question 20 says the limit of, we want to find the limit of f of x, sorry, it's going to start over right here. Okay. What? I'm a little bit. So the limit as x approaches 7 of f of x over g of x. So one of the properties of limits is if the limits are both going to the same number. So for instance, our f of x, or the limit of x approaches 7 of f of x equals 7, and the limit of x approaches 7 equals 14 of g of x. If we have the limit of f of x and the limit of g of x, we can easily find the limit of f of g over, or the limit of f over g. So essentially, you're just using the numbers and just kind of plugging them in. So in this case, we're just doing the limit of x approaches 7 of 7 over 14. 7 over 14 can be reduced to 1/2. We can reduce it to 1/2. So essentially, we have the limit of x approaches 7 equal, or of f over g would be 1/2. Does that make sense, guys? It is not. You're just kind of plugging in numbers where they're kind of assigned to go. So yeah, that's question 20. Okay. So now question 21, we're kind of doing the same kind of concept, except something a little different. Yes.
If the limit f of x as x approaches, if it was 6 and then g of x, x approaches -6, can you still do it?
They need to be the same, and usually when it comes to the test, they'll be the same anyways. I don't foresee it to be two different things. Alrighty. So question number 21 kind of goes off the same kind of concept where you can apply different mathematical rules to them. So we have the limit of x approaches 6 of f of x equals 25. However, we want to find the limit as x approaches 6 of the square root of x. So essentially, all we're doing is finding the different mathematical stuff they tell us to do. So in this case, they want to find the square root of f of x. So all we're going to do is plug in 25. All right. So all we're doing is just plugging in 25 for f of x. We know the square root of 25 is 5. So that means the limit of x approaches 6 of the square root of f of x would equal 5, because we're just square rooting 25. That's it. And it's just kind of almost like the beginning of the problem, well, the beginning of the course, just basic algebra. Does that make sense, everybody? Cool. Does that make sense, Mary? Okay. I know it seems way too easy, but it's not too bad. Alrighty, question 22. We're kind of, yeah.
X approaching 6 could be x approaching anything.
Yeah, this 6 is arbitrary. We can make it x approaches 7, 5, a billion, as long as they're both the same. Well, essentially, there's only one of them, so yeah, it doesn't matter what that number is. This number has no effect on our problem. Yeah. All right, so question 22 on the final exam prep. We're kind of jumping the gun on some more pre-calc. So here, we want to find instantaneous rate of change. Now, when it comes to instantaneous rate of change, when it comes to position, in this case it says for the given value, so it says g of t equals 3 minus t squared, and we want to find the instantaneous rate of change at t equals 4. So the one thing to do here is pretty straightforward, is you're basically taking the derivative of that function. So the derivative of g of t would be negative 2t. Now, do you guys see how I got that? Yes? Cool. It's just kind of the shortcut. I'll just kind of run through it one time. T squared, when you want to find the derivative of something, you bring down the power to multiply the number in front, so this becomes 2t. When you bring down the power, you have to bring it down by 1. So essentially, we end up with 2t as our derivative. And you can do that with any number of different values. So essentially, our derivative of g would be g prime equals negative 2t. We want to find the instantaneous rate of change at t equals 4. So you can imagine all we're doing is just plugging in 4 after we find the derivative. So g prime of 4 equals negative 2t, or negative 2 times 4. So our instantaneous rate of change would be negative 8. Does that make sense? Pretty straightforward. It's not too bad. You're just essentially finding the derivative, plugging in that number when you're doing instantaneous rate of change. When you see instantaneous, that's kind of a hint to taking the derivative. Make sense, everybody?
If you get a negative like this, it's still correct?
Yeah, it's still correct. It just means we're kind of slowing down in a sense. But don't worry about that too much. But yeah, we can still have negative numbers. Yes?
Why did the 3 go away?
Because when you take the derivative of a constant, it is 0. So essentially what happens with the 3, technically the 3 has a variable of t to the 0. We know t to the 0 is 1, so we just kind of do what we did here. If you multiply 0 times 3, we end up with 0t, and anything to the 0 becomes 0, or t to the negative 1. But this whole thing becomes 0 anyways, because 0 times anything is 0. That's why the derivative of constants is 0. So that's kind of a rule you guys could write down. Alrighty. So here, now we're just kind of jumping straight into derivative stuff. Okay, so here they want you to find the derivative, and you're just doing that little shortcut rule with every single term. So here we can say the derivative is, we bring down the 3 and you bring it down a power. So you have 3x squared. Does that make sense, guys? Pretty straightforward. You're just kind of doing little shortcuts. Here we're doing the same thing. 2 times negative 10 is negative 20. You bring the power down by 1. It's going to be 20x to the 1, or just 20x. 12x, you kind of bring this invisible 1 down, it becomes 12, but when you bring 1 down to the 0, it becomes 1, so essentially it is just 12. Derivative of a constant is 0, so you don't have to write anything for that. Does that make sense? That's just the shortcut for derivatives, super useful towards the later part of this course. Yeah, so this is essentially y prime, and that's it for that. Does that make sense? Cool. Alrighty, so now we're going to do more derivative stuff. But there are 3 rules, or one's kind of a unwritten rule, and we have 2 general rules that I like to go over as well. So the first rule is called the power rule. And this is number question 24, or question 24 on the practice quiz, final practice quiz. All right, so essentially we're doing the same thing. We're trying to find derivative. However, we do have a little bit of an extra step we have to do. This is the power rule. So you're going to treat it the same way as we did for the shortcuts. As an example, if we have x cubed, we know we bring down this power, and then we bring down, or we bring it out in front, and then we bring down the power. So this is essentially 3x squared. However, we do have something inside inside here. So all we're doing is kind of the same step. We bring down the power, so it becomes 3. You rewrite the inside. You do not touch it. You just leave it as is. You bring down the power by 1, so it becomes 3 times x minus x to the cubed minus 1, all squared. But the extra step into doing this is you need to multiply by the derivative of the inside. So you need to find the derivative of the inside separately and multiply it out next to it, essentially. So we can kind of, actually I kind of did the derivative here. We know the derivative of x cubed is going to be 3x squared, and the derivative of negative 1 is 0. So essentially our derivative is 3x squared. So we're going to multiply that by 3x squared. And that's essentially it. You can simplify. It depends on how your answer is being laid out. Since this is just a single term, we can go ahead and kind of multiply it by the other single term on the outside. So that becomes 3 times 3x squared, which is 9x squared. And then you can just rewrite the inside as is. Does that make sense for you guys?
On the test, well, you had a very similar question to that, the inside was left alone as it is, and the outside was just the whatever 9.
Yeah. So yeah, for instance, if we had like 2x in the inside, then our number would just be a 2 on the outside, and then we multiply that by the outside number. Want me to just kind of quickly go over that real quick?
Yeah.
Yeah, sure. So kind of like a quick example, if we had something like this, 2x minus 1 squared, if we do the power rule to this, we bring down this 2, rewrite the inside, bring this down by 1, and then you can multiply by the derivative of the inside. The derivative of the inside will just be 2, right? 2 times 2 on the outside will just be 4. You have 2x minus 1. Now, since there is kind of like, there's not a power here, you can distribute, but it's really up to you. Technically, this is all the same answer. This becomes 8x minus 4, but these two answers would technically be correct. The trick is making sure your answers on the test match that. So yeah, that's another quick example of that. Let's see what number. All right, cool. So number 25 is the product rule, and this is one of the other rules when it comes to derivatives. All right, so we have y equals this nice function, and here we're going to be doing the product rule. Now, what warrants a product rule is we essentially have a product between two different functions, essentially. So here, the formula could be represented as f of g prime plus g times f prime. Now, what this means is you're taking the derivative of one function, multiplying it by the original other function, and I'll just write it out because it's kind of hard to elaborate. So here, what I like to do here is kind of separate our two functions and then find those derivatives of those two functions. So we have our first function, and it doesn't matter which one you label f or g, it's going to turn out to be the same answer regardless. So if we know that our f is this and our g is that, we can go ahead and find f prime. F prime would just be 10x, because you bring down the 2 times 5 is 10, bring down the power by 1, it just becomes x to the 1, so it's just 10x. And then g prime would just be 5. So we have our f, our g, our f prime, and our g prime. So now we can just kind of plug it into the formula of our product rule, and that should be it. So y prime equals f. So I'm going to write f down, which is 5x squared plus 2. You want to put parentheses? I like to put parentheses because it groups things so it doesn't mark it wrong, essentially. Times g prime, which is 5. So we can kind of tag that out in front, plus the opposite, which is g, 5x minus 4, times f prime, which is 10x. And we can just kind of stick that out in front as well. Essentially, this is correct. You can distribute and simplify. It just depends on how your answer is being laid out. And that's really up to what happens on the test. But I'll simplify this. Since we do not have like any powers here, we can go ahead and distribute. So this becomes 25x squared plus 10 plus 50x squared minus 40x. So all I did is I just distributed separately twice, individually, and now we're just going to add like terms. So 25 and 50 would be like terms. 10 and 40 cannot be added, so I'm just going to write them next to each other. And this is also a correct answer. They're both the same. It just depends on simplifying, and it depends on how the answer is being laid out on the test. Does that make sense, everyone? Yeah, it's pretty straightforward, not too bad. Alrighty. Okay, so question 26 is also a product rule, so I'll just kind of run through that kind of quickly. So again, we have a product or a power rule in a sense. So you're just going to bring down this 2, rewrite the insides, do not touch the insides, bring the power down by 1, and then multiply by the derivative of the inside, which is going to be just 3. These two are kind of individual terms on the outside. You multiply them, giving you 6 times 3x plus 4. And that's essentially the derivative of that. Does that make sense? Pretty straightforward, just like we did before. Alrighty. So we do have one more rule to kind of go over, and that would be the product rule, or sorry, the quotient rule. Now the quotient rule is similar to the product rule, saying we do have two different functions being differentiated. Alrighty, so here what warrants the quotient rule is that these two are being divided. So if you see a division between two different functions and they want you to find the derivative all you're doing is finding the derivative of the function. So one little rhyme I find to help me out is called low d high minus high d low all over low squared. So essentially what that means is this is going to be our high and this is going to be our low. So when I say low d high, that's essentially saying low, or actually I'll just write the formula out. Low would be, and if we have f over g, low would be g. D high is derivative of the high, which is derivative of the top, which is f prime, minus high d low, which is just the opposite, all over low squared. All right, it's kind of a little rhyme I learned this with, but essentially you're just taking derivative of the top, multiplying by the bottom, minus the opposite all over the bottom squared. Low d high minus high d low all over low squared. Right? Does that make sense, everyone? Any questions on that? So again, we can kind of set our two different functions as f and g and then find those derivatives individually. So if we know f is 7x, we know that f prime is 7. If you know that g is this, that means we can say g prime is 5. So here, we're just kind of plugging in like we did for the product rule. So we have y prime equals low d high. So we have 5x plus 1. D high, which is derivative of the top, which is just 7. So we can stick that out in front. Minus the opposite, high d low. So 7x minus 3. D low, which is derivative of the bottom, which is just 5. All over low squared. And the low squared is just as 5x plus 1 squared. Now usually you won't have to do anything further than this. The top can be reduced, so I guess I can reduce that for you guys real quick. Actually, I want to move forward. We still have a decent amount of stuff. But I can simplify this for you afterwards. But it's just simply simple algebra. So yeah, there is the quotient rule. All right, so question 28 is also a quotient rule. We do have a little bit of a extra step. I'm going to skip that for now so we can move forward. Question 29 is a power rule, and I'm going to do that one because that one can be complex. All right, so here we're doing power rule again. Same thing. We want to bring the power down, rewrite the inside, then multiply or bring the power down by 1 now. Now rewrite or now multiply by the derivative. In this case, since we do have more than one derivative, we're going to put this in parentheses. So we're going to do the derivative of the inside. So this is 32x cubed minus 6x. The 3 becomes 0, so that would be that. Does that make sense? Just kind of ran through it. So now we don't have like a single term on the outside, so technically this is the correct answer, or you can multiply it out by the term in front and simplify that way, but this is correct.
You just divide the center of the original term and do the outside.
No, not divide, multiply.
Derive.
Oh, yeah, derive, yes. Yeah, you're just taking the derivative of the inside. Yeah. So it's just like other power rules, it's a little bit more intense. So question 30 is a graph. Okay, actually I'm going to do that. I'm just going to make one up for you guys. All right, so here, we want to find where we have whether this function is increasing or decreasing. So I'm just going to do something fairly similar. Now this point here is going to be 3. All right, so when you want to find when something is increasing or decreasing, I like to compare it to riding a roller coaster. You're decreasing when you're going down on a roller coaster, and whenever you're looking at a function to decide whether it's increasing or decreasing, you always look at it from left to right. So just kind of like scanning it down here. So if you were to essentially ride a roller coaster of this parabola, you'd be decreasing all the way from here to this point. Does that make sense? So it's just kind of saying we're decreasing from negative infinity to positive 3. And that is when we are decreasing. Now the reason why it is negative infinity is because this essentially moves on forever. So you're just looking at it from left to right. You don't really, you're not pulling the negative using y values. You're just looking at the x values between the graphs. So here this goes on forever to the left. So it comes from negative infinity and it goes to 3. So with that being said, we can easily find where we're increasing when we're riding this roller coaster upwards. So increasing would essentially be the opposite, 3 to positive infinity. Does that make sense? Yeah. So all you care about when you're looking for increasing and decreasing are the x values. You're just looking at it from left to right. You don't really care about the up and down values of the graph. You're just looking at it from left to right. So essentially we are decreasing from negative infinity all the way to 3, and then we're increasing from 3 all the way to infinity. Make sense? Cool. Okay, so question number 31 kind of deals with finding increasing and decreasing. However, we don't have a graph. So what we need to do is essentially find our critical values of the function. So the function would be all right, so we want to find where this function is increasing and decreasing. Obviously, we can't really sketch this graph in our head, and we can't use graphing calculators on the test, so we don't know where that is. So one way to do it is to find the critical values. So to find the critical values, we're going to be doing what we did last chapter, is taking derivatives. So we're simply taking the derivative of this whole function. So this will be 12x squared minus 30x minus 72. You guys see how I did that? I just quickly took the shortcuts between all of these different terms, leaving us with that derivative. The 1 goes away because the derivative of 1 is 0. So here we need to solve for when the derivative of y is 0. So essentially we're doing this. 0 equals this whole derivative. So here we need to factor. What we can do is we can divide this every single term by 2. So that leaves us with 2 on the outside, and then 6x squared minus 15x minus 36. Cool. So you guys see how I got that? All I did is I factored out the 2, leaving me with 6, 15, and 36. So now we're going to factor out. Now since we do have, we can actually factor this out one more time, and we can divide, we can kind of factor out by 3. If you guys can find the biggest number to factor out to begin with, this kind of saves you this step of doing it again. So I'm going to factor out by 3. So I'm going to have this on the outside, leaving me with 2x squared minus 5x minus 12. So as you see, if we essentially divided by 6 to begin with, we'd end up from here to here. We just kind of save a step by doing that, but I didn't do that, sorry. So we essentially have 6 on the outside and then all of that. So now we're factoring out. So here, since we do have a number in front, I'm going to be factoring out using AC method. AC method is essentially A times C, and A in this case would be 2, C would be 12. So A times C would be 24. Now the trick is finding two numbers that multiply to 24 but add up to -5. Now this could be the trickiest part of this problem because you gotta kind of find trial and error to which numbers can do that. So we know that 8 and 3 can get us there. 8 times 3 is 24, and a mixture of 8 and 3 can give us -5. Since the 5 is negative, we would have to make the 8 a negative. Does that make sense, everyone? When we're doing factoring, we're doing the AC method, we want to find two numbers that multiply to this 24, and this 24 came from A times C, and then we're adding to this middle term. That make sense now, Mary? And then now, question?
Is it -24?
No, it's positive because 2 times positive 12 would be, oh yeah, you're right. Shoot. Positive 3. That would be negative. Oh yeah, you're right, I'm sorry. This would be a negative. Thank you for catching that. So, yep, this would be -24. So, yeah, so we have -8 times 3 is -24, and -8 plus 3 is -5. So, the second part of the AC method is we divide by our A, and we simplify if we can. So we can simplify this by 2, so it becomes -4 over 1, and then 3 over 2. Okay, so this essentially is our factors. So we're going to go back to here. Now the bottom number is going to be the number that holds the x. So this becomes x minus 4, and this becomes 2x plus 3. Now there's different ways of factoring. If you guys have an easier way that is, you find easier for yourself, go ahead and do that. But this is one way of factoring. So remember, we're trying to find the critical values. Critical values, we set it equal to the derivative of 0, or sorry, we set y prime equal to 0. So we're essentially saying 6 equals 0, x minus 4 equals 0, and 2x plus 3 equals 0. However, we cannot say 6 equals 0 ever, so this we don't have to worry about that. So we only care about our x's, and here we're just solving for when x equals 0. So in this case, x equals 4, and x equals -2 over 3. Does that make sense? Just quickly solving, setting it equal to 0. So yeah. So now that we have our critical numbers, the way I like to solve, whether it's increasing or decreasing, is I like to put it on a number line. So the -3/2 goes first, x goes second because it's positive. So now all you're going to be doing is picking 3 numbers in between these points to give you basically whether it's a positive or a negative. So the easiest number to begin with would be the 0 because it's between negative and positive. So we're going to plug 0 into here. And when you put 0 into here, we end up with 2 times 0, which is 0, plus 3 is a positive 3. And 0 minus 4 is a negative number. So we can say that -4 times 3 is a negative number. We don't really care about the value, we just care about the sign, right? So that's why I'm not putting too much emphasis into what that number is. We just want to know whether it's a positive or a negative. So we know that a negative times a positive is a negative. Now, a good kind of rule of thumb, usually if there's a negative here, that means these two sides would be positive. Now, to make sure, we can go ahead and plug in, but 90% of the time, they're always going to be alternating. But I would suggest to plug in numbers anyways. All right, so this is essentially saying where we're increasing and decreasing. Now remember, we only look at it from left to right. So here, we're only increasing when it's positive and decreasing when it's negative. Negative here. So I'm going to kind of write it off here. So here we're increasing from negative infinity all the way to -3/2. And then again from 4 to positive infinity. Now it depends on how the test is laid out, but usually you can find a union between those two. And then this is a u, not a 4. And that's 4 to infinity. Does that make sense? And decreasing would be the inside, negative 3/2 to 4. And that's essentially that. Now we do have 10 minutes left, so this is essentially the problem for 31 says what are the critical numbers? These are the critical numbers, and they ask you where it's increasing or decreasing. This would be increasing, this would be decreasing. So yeah, that's number 31. Now I do want to touch integrals really quick. Number 32 is the same thing, find the critical values. Number 33 is find the derivative twice. So you just take the derivative one more time after you take it again. So when you see something that looks like find f double prime, when it says find f double prime, that just means take the derivative 2 times. Take it once, write that function down, and then take the derivative again. And that's what double prime means. And that was question 33.
Is 32 just the same as kind of the same as 31?
Yeah, 32 is just find the critical values. Yeah, so. Alrighty, so I'm gonna be skipping a couple here because I do want to touch on the integrals. Alrighty, so number 38. So here we have integrals. Now, what an integral is basically the antiderivative. It's just the opposite of a derivative. So here we want to find the indefinite integral of 6x plus 5. Now, for derivative, what we did is we multiplied the power and then brought the power down by 1. Now we're essentially going to be doing the opposite. We're going to bring the power up by 1 and then divide by that power. So for instance, we know the power here is going to be 1, so we're going to bring that power up by 1, so it essentially becomes 6x squared, and then divide by this new power, which is 2, right? You can reduce this and it becomes 3x squared. Now, a good way to check yourself to make sure you're doing it correctly is take the derivative of what you just integrated. And the derivative of 3x squared is 6x, so you did that correctly. So integrals of constant numbers would just be that number attached with a variable, 5x. Does that make sense? Pretty straightforward. You're just attaching a variable to our constant when we integrate. Now, since this is an indefinite integral, now what that means is there is no bounds. We're just essentially, this would be it. However, we do have to add a plus c at the end. Now, and that's pretty much it for indefinite integrals. Now you're essentially just kind of reversing the derivative. Oops. So yeah, and this was question 38. Cool. Now question 39 is a little bit more intense. We got 3 numbers to worry about. Indefinite integral of 3x squared minus 8x plus 5. Again, doing the reverse. You add the power by 1, divide by that new power. You add the power by 1, it becomes 3. 3 divided by 3 becomes x cubed. 3 and 3's cancel out to become 1, so you just have x cubed as your power. Here, this becomes, you add the power by 1 and divided by the new power, so it becomes 4x squared. You add the power by 1, it becomes 2, divided by that 2. 8 divided by 2 is 4. Does that make sense, guys? Cool.
So you
Question?
divide by the power that you're adding?
Yes, the new power that you made, yeah. And then for the constant, you just stick on that x. And since this has no bounds, it is plus c. Cool. There's that. Alrighty. So here, question 40, it talks about find the cost function if the marginal cost is some cost function. Now remember, they give you the cost function of 12x minus 5. they want you to find the c function. We have c prime, we just need to find the c function. So here, all we're doing is we're integrating, and that's it. So we integrate this real quick. That becomes 6x squared minus 5x. Now on word problems, usually there will be a fixed cost. That plus c will be your fixed cost. So your fixed cost in this case is plus 9. And that would be question number 40. So whenever you see fixed cost when it comes to integrating, that is most likely going to be your c. Now one last problem is we have a definite integral. So a definite integral is similar to a regular integral, except now we have to do some calculations. All right, so indefinite integral, or definite integral, we're just integrating like normal. However, we do have to subtract some things. So we're iterating this. You add the power by 1, it becomes 2. Divide by that new 2, it becomes x squared. If you're not sure whether you integrate it correctly, just take the derivative, and if you end up with the same thing, you did it correctly. Since this is x squared, now this is going to be plus 8x. Now we don't have a plus c here because this is definite. So what we do is we have some calculations we need to do, and this is how you would notate it. So here we're essentially doing the 3 plugged in minus the 2 plugged in. Now what I mean by that is we're doing 3 squared plus 8 times 3 minus, now remember you want to minus as a whole because a negative sign will change everything, 2 squared plus 8 times 2. And now you're just kind of simplifying it out. So 9 plus 24 minus 4 plus 32, parentheses first, 36, 24, 9 plus 24 minus 36. Since these have the same sign, so you go from left to right. So 9 plus 24 is 33 minus 36, and this equals negative 3. And that would be the process of doing a definite integral.
So you are using the 3 and 2 as for b or a.
Yeah.
Okay, and you're putting them for the x.
Yeah. You're essentially just kind of plugging in, you're solving for the area essentially. Okay. And you're just plugging in the b minus you plug in the a.
Okay, fine.
Yeah. And that pretty much covers it. I ran through a decent amount of the questions that I feel like it's very similar to the test. Of course, usually the test won't be so intense where we have these long problems where it took me about 5 minutes to do, but yeah, that's essentially it. If you guys have any like personal questions, I can answer them like afterwards. So yeah, thank you guys for coming. And if you guys want to see this again, this is on the YouTube channel, UCF SARC. In this case, this will be ECO 3401, Quant Tools 1. If you want to kind of recap what I did beforehand, and then you can kind of pull up your practice exam and just kind of follow along with me if you don't have your computers here now. YouTube UCF SARC. And then the class number name would be ECO 3401. And it should say Quant Tools or something along the lines of that. So you can kind of recap what I did here. All right, well, thanks again, guys, for coming, and good luck on your test.